So we are now doing lab 4. So here, this is just Valgrind and stuff. So, and that we've done in lecture as well. So I think there's no point to doing that. So here we're doing a TOF. This converts an input string to a double. So ATOI works like this. So basically, what is ATOI doing? So we're saying, okay, like the sign by default is 1. The sign is either 1 or -1. And then if str at I, meaning str at 0 is minus, then the sign flips, it becomes -1. And we advance the index by 1. So now that we've done it, essentially what we're doing is we're saying, okay, so kind of keep computing the result. So if the number is something like this, then initially the result is 4. And then we're saying times 10 plus 5, so that's 45. And then times 10 plus 6, so that's 456. And then times 10 plus 4, so that's this, times 10 plus 5, so that's this, times 10, and then 4, like this. So, okay. So now what we want to do is the same thing, but for doubles. So that means that we'll also have a decimal point there. So, being double 4. And this is this. So this is this. So, and now what I'm going to do is, okay, so and now I'm doing okay. So what do I want to do here? So essentially, if I have something like 3.1415 or something, right? So I want to, up until the decimal point, just do the same thing. So read this guy in. And then after the decimal point, I want to do the same, but the other way. So if you think about it, if I have a number like this, how do I read it in? Well, so I can say, okay, so I start with 0, and then I can say divide by, so +1 divide by 10, right? So +1 divide by 10. And then I can say, okay, so this is this, and then I need to again divide this by 100 and add this, and then divide this by 1,000 and add this, divide this by 10,000 and add this, and so on. So this is how I'm going to do it. So I'm going to do the same thing with the sign. Initially, it's 1. And this is the result. So I'll first go up until the I'll first go up until the dot, right? So I'm going to say, okay, so if this is a minus, then update the sign, and then I'm at high. now I'm gonna go up until the dot. I want to do it with a while loop. So the stopping conditions would be either that I got to the dot, or I got to a null. So I'll keep going while it's neither the case that str_i is dot, nor is the case that str_i is the null. And here I'm doing exactly the same thing as in the handle. So that's this, and I'll keep my format with this. So, okay. So now if I've gotten to the null, I'm done, right? So I can say if I'm at the null so that I don't worry about it anymore. I'll just return sign equals result, and that's it. If not, then I advance past the dot, and now I got to process the decimal part, right? So how do I process the decimal part? So I start with the decimal part being 0, actually. And what I'll do here is I'll keep track of the factor. So initially the factor is 0.1. So if I want to add this guy, I want to add factor times 1, and then factor divided by 10 times 4, and then factor divided by 10 again times 1. So, okay. So now I'm going up until the null, and I'm dividing by the factor every time, and I'm adding 1 every time. So here, what I'm doing is the same thing as in the handout, right? So the value of the digit times factor plus whatever I already had. And then the next time I'm using the factor, I'll divide it by 10 again. And now I'll just return the sign of result. So this is this result. So this is kind of the whole part plus the decimal part. So that's like this. Let's test it. So this would be this. And here, indeed, this. So one thing to note is that C, of course, does not know what does not know how many digits you mean to print here. So there is a way, which we haven't done in class, to specify that you want a particular number of digits after the decimal, like this. So you can say 0.4, and then it'll print 4 digits after the decimal. If you know that that is what you want, you can also say 5, and it'll print the 0 after as well. Okay. So, all right. So that's this one. So now we've done this. So now we actually want to read in a file that looks like this. And I guess we want to add them up, right? So, okay. So what does this mean? So essentially, we are going to be reading the file, and then we're going to be skipping everything up until equal space, and then we're going to use my ATOF in order to read this guy. So, okay. So I'm going to say, reading a file. So this would be the usual thing. So do it a different way, the way it's done in the handout. So reading in a line that's at most of size 1000. And then I'll keep reading. So I'll keep reading. So if I'm done, it's going to say that I'm done. If I'm not done, then I keep reading. So here, what we're doing is not quite right. So what I need to do is I need to first figure out where the equal sign is, and then I can use the myATOF function, right? So the way I'll do it is I'll say, okay, so there's a helper function, so I'll call it find after equal. And what we're going to do here is we're going to say we start with I equals 0. We go up until the equal sign. We keep increasing until we find the equal sign. And then what we want to do is we want to actually return I plus 2 because we also want to skip the space after the equal sign. So now that we're equipped with that, we can say, okay, so read in. So we want to supply the string. So the string would be line plus find after equal line, right? So this would be the index of the beginning of the constant. And this would be the address of the beginning of the line. So, okay, so to test it, I need to create the file. That would be like this. And now the constants, maybe like this. And now we are going to say constants.txt. Like that. Here, we'll print the result. Let's run this. And we're getting something like this, which does not seem quite right. So here we are at 3.14. So we got 3.10 for some reason. So let's trace it. Okay, so we got the line. So the line is currently this. Oh, I see what happened here. Oh, no. So the line is pi equal. That's good. So let's see what the value is of this guy to make sure that that seems plausible. So the value here, that is 5, which is 0, 1, 2, 3, 4, 5. That seems right. So let's step in then. That's just us finding the phi. But we did not step into my ATOF. We stop and put a breakpoint here. So we're here. So let's see what STR is. So STR does start with 3, so that's the right STR. It's not the case. So we are now going to be incrementing the result. So result is 1. It seems like we stopped, which is good. So it's not null. So we are going to go on because we need the fractional part. We are now saying, okay, factorize this. So decimal is 0.1. And now decimal is becoming 1/4. So that seems fine. And now result is 3. Decimal, however, seems to not be correct. So what happened here? I need to go back, I guess. Continue. So we're over here. So factor is now 0.01. STR at I is 4. We do want to add 4 times 0.1. So this is correct. Factor is now smaller. So here it seems like there was a problem. I think it's that here 4 was the last one, but we did not stop for some reason. I think the reason is that there was a new line over here, right? So one character here was, so the character here was a new line, which was neither null nor nor a digit, so did not consider that. So what we'll do is we'll say, while it's not null and also not n, like this, and we'll similarly do it here. So let's try it again. So we now printed out 3.14, which is correct for the first one, but not correct for the other ones. Okay, so the first time the sum is 3.14. We get another one. So line is currently this. So this is G is equal to 0.000 whatever 7. So this is very small, so it would make sense that it would not change. And we are now, so, and what happened here, right, is we got the last line, but we never actually added the thing, right? Because we're saying sum plus equals, and then we do f get s. So that's unfortunate because that means that we missed the last element. So how do we fix that? So what we want to do probably is we want to say, okay, so over here we do have get s, and what we want to do here is we want to add the sum outside the while. So over here, you can also do it using a do while loop, but that's not something we've done in class. And what we can do now is we can say, okay, so the sum's here. Actually, that would not work either. So over here, so after we are over here, we also want to add the last one. So like so, and this is only if line is actually not null. So I'm going to say if the line actually exists, then we'll do it. And that means that here we need to initialize it to empty. And now that's fine. All right, so that is lab 4. Was there anything else? Oh, yeah. So here we have this kind of code. So here we define a student, and here we have a change name wrong. So why is this wrong? Well, it's because you're changing the local variable s, but that doesn't mean anything outside the function, right? Because you're sending this entire thing, so including kind of 3 characters in the name and the age, you're copying the entire thing, you're copying it to s, you're changing it, it doesn't change anything. So this is different because you're sending the address of the student and you're changing the contents of the student in the caller function. This also works because this is just a different way of changing the contents of the student in the caller function if we're calling the address of the student. So calling using the address of the student. So here, what we're saying is in Python, we store student with a name AB and age 20, like this, just as a list. So what you're asked to do is to explain why each of the C functions does not have an equivalent in Python. So why doesn't it have an equivalent in Python? Well, because if what you're doing in Python is something like this. And then the main function, you are doing something like this. So what's happening here? So if you're doing it like this, and this is really the only thing that you can do in Python, right? What you're doing is you're sending the address of the student, right? So in Python, this student and this student are aliases. And then you're going and changing the string from whatever it used to be to the address of the J. What we're doing here is different, right? So what we're doing here, this doesn't exist in Python at all, because in Python, the only thing that you can do when you're passing a variable to a function is to pass the address. If you remember from 180, what you're doing is you're copying in the variable table the address of the caller variable to the address of the variable inside the function, right? So this doesn't exist. Like there's no such thing as just copying the entire thing in Python. So that's out. This doesn't exist because even though that kind of construction does exist in Python, in fact, that's the only thing, you're always passing an address. You cannot change the contents of a string in Python, right? So strings are immutable. Here, what we're doing is we're changing the first character of the string to something else. Doesn't exist. What we're doing here is the same thing. Again, this is the same string. We're not changing the address here. What we're doing is we're copying B and then we're copying a null to PS name. That does not exist in Python, right? Because again, you cannot change the contents of the string. Okay. So that we've already done. And now what we want to do is we want to write a C function that works the same way as the Python function. So let's go back to what the Python function is. And let's write out the memory diagram here. So here we'll have the globals. And we'll have the locals. We'll also have memory table. Something like this. So we have A stored somewhere, and we have B. So we have 20 stored somewhere. And then we have the list stored somewhere. So this would be at 1020, at 1040. And now we have our globals. So the globals would be this. So this is going to be stint, and the address is going to be at 1080. So, okay. So now this is set up. So now we are saying change name student. So that means that we'll also have this. And what happens is this just gets copied to this. So the local student here also has the address 1080. We are now saying student 0 equals J. So what does that mean? It means that there is a J somewhere here. And then we also want to say, okay, so student at 0 equals J. So student at 0 here, that is now going to be 1100. So that's the change name in Python. How would we write the equivalent thing in C? So in order to be able to write the equivalent thing in C, we need to be able to change an address that's stored in student. So that means that rather than writing something like this, where we cannot change name to something else, we can change the contents, but we cannot change this. This needs to be a pointer that can be changed. So we've done it a bunch of times, of course. So that would have to be like this. So now what we'll do is we'll create the student like so. And then in order to change name, we'll do this, right? So here, what we're doing, if we change the name, is we're just saying, okay, so it used to be that s.name was the address of the J, and now we'll make s.name the address of the. So what we do is we send the address of S so that we get to change the contents of S. And then we just say S arrow name. So meaning the name inside S used to be the address of the J, and now it's the address of the do. So let's do the memory table. So you store like the J and so on. We make it shorter. So this is like J and D. So here, S is going to live somewhere, right? So maybe, for example, here. So maybe this is S. And S is going to be the address of the J initially, and then a 20. So the address of the J, so this would be like 1000, and maybe the 20 here. So all of this is S. Then when we call change name, what we're doing is we're calling change name with 1032. Address of S is 1032. This is where S lives. S has 1010. So somewhere over here, the local S and change name, which we might call PS, is going to live here. And now we're saying S name equals, and sorry, we didn't store new name. So new name is 1016. That's like this. And now we're saying go to 1032 and change this guy to D. So change this to 1016. And now the name of the student has changed. So the point here is that this is the equivalent in this is the equivalent of Python more or less, right? So you are always sending in addresses in Python. There's no sending in anything else. And then what you can do with strings is if you have a string that's an address, you can say it used to be an old address and now it's a new address. All right, I'm going to take a break again and go back to project 3, lab 3.